Hello everybody. This lesson will be going over the squeeze theorem. It's going to be a quick lesson. So consider the function f of x is equal to x squared sine of 1 over x. The function is going to look something like this. It shoots up and it's sinusoidal, so it goes up and down within these bounds, and then eventually it gets to 0, and then it starts getting wavy again. Okay? So if we consider this function, if we look at it, f at 0, coming from the left and from the right, it gets squeezed in to 0. So how do we prove this algebraically? Okay? We can consider sine of x, and we know that it's between -1 and +1. Okay? And then we can also say that sine of 1 over x is also between -1 and 1, right? Okay? So now what we're trying to do is we're trying to make this look like this. So the next thing we're going to do is multiply by x squared on all sides. So we're going to have negative x squared is less than or equal to x squared sine of 1 over x is less than or equal to x squared. And then let's take the limit as it approaches 0. So we're going to take the limit on all sides as it approaches 0. So limit as x approaches 0 of negative x squared is less than or equal to the limit as x approaches 0 of x squared sine 1 over x is less than or equal to the limit as x approaches 0 of x squared. Notice we can evaluate both the left side and the right side, so we know that the limit as x approaches 0 of negative x squared is 0. Okay? We don't know what the center one is. Limit as x approaches 0 of x squared sine 1 over x is less than, we can evaluate this one on the right too. Limit as x approaches 0 of x squared, that's 0 as well. So notice on the left and the right side, they're both 0. And so therefore the center term has to be squished to 0. And that's the proof of the squeeze theorem.